Imagine if you had taken a poll of physicists in 1902 and had said, here's this guy, Albert Einstein, who's a patent clerk. Should we give him some money to develop his kind of outside the box ideas? I mean, chances are that it would not have reached consensus of 20 physicists at that time. 2 that you've already done and 1 that you'll never do.
I thought this was my personal protocol, but it turns out to be a
I wrote up a
global
long list
optimum.
that maybe we need at the National Institute of Health, or we need another institute called the National Institute for Irrelevant Ideas.
Welcome to the post-AGI podcast. I'm your co-host, Sriram.
I'm your co-host, Shavik.
And
Welcome to the show.
Thank you so much. I'm glad to be here.
Yeah, thank you so much for being here. Stuart leads the Good Science project. Can you tell us a little bit about it, and then we can dive into it?
Sure. The Good Science Project, I think of it as like a little think tank. It's focused on improving federal science funding and policy and the organization of science. The idea is that a lot of our scientific ecosystem is too slow and it's too focused on narrow goals rather than being open to as much innovation and curiosity, different research as would be more optimal. So we do a lot of research writing and policy briefs, and then talk to folks in DC, typically in DC, who work for major federal agencies or for Congress and the White House.
Amazing. As a former academic, I can deeply empathize with the set of problems and the solution that you're putting forth here. One of the things that, as you mentioned there, this open-ended research, curiosity-driven research, which actually contributes to idea diversity and the exploration of the solution space, much richer than what industry, which is just optimizing for immediate outcomes, can nominally drive. I think this is one of the big roles of academia. But one trade-off or tension that I sense is when you try to do open-ended, curiosity-driven research, the value function of what is valuable is very hard to ascertain. And so usually, academia relies on the rule of thumb of go with the experts. And so the experts basically bless certain areas of open-ended exploration,
Right.
and which are nominally biased towards the areas that they were actually experts in. How do you think of solving this problem?
Well, it is kind of a paradox that most of our federal science funding, let's focus particularly on NIH and NSF, is handed out with strongly based on the recommendations of outside experts who participate in peer review panels at NIH, which are called study sections, or merit review at NSF. And that does make a lot of sense for a lot of science. I mean, science is a kind of social enterprise in which, if you're doing great science, chances are that other people within your field will recognize that at some point and want to reward that. At the same time, if you look at the history of true scientific breakthroughs, they're not something that would have been approved by a consensus panel of the peers in that field 3 to 5 years ahead of time, right? I mean, imagine if you had taken a poll of physicists in 1902 and had said, here's this guy, Albert Einstein, who's a patent clerk. Should we give him some money to develop his kind of outside the box ideas? I mean, chances are that it would not have reached consensus of 20 physicists at that time. And the same can be said for many other breakthroughs that have happened. I mean, almost by definition, a scientific breakthrough is not something that everyone already believes. So we have this kind of paradox in that we depend on scientific consensus as it develops over time. Yet we need to find ways within this kind of massive bureaucracy that hands out tens of billions of dollars a year to make space for ideas that are not consensus driven. And I've often kind of joked that maybe we need at the National Institute of Health, we need another institute called the National Institute for Irrelevant Ideas.
Ideas like the Nobel Prize.
Yeah, right. Almost by definition, making a place that deliberately tries to seek ideas that are not particularly favored, like mRNA in the 1990s when Katalin Karikó couldn't get any NIH grants.
Wow, I didn't know that story.
Yeah. Oh, it's a great story. Well, it turns out well in the end, but it was sad for her at the time because she was a Hungarian immigrant at the University of Pennsylvania. She wanted to work on mRNA. Everyone else thought that's crazy. mRNA is so fragile. You could never get that to work as a vaccine. She was originally on the tenure track professor, but she got demoted repeatedly and ended up basically as a lab technician in another professor's lab who kindly took her on. That's the point at which most scientists would have abandoned academia altogether. Because if it's embarrassing, right, at best, and your salary's being cut, and like you would end up doing something else. And she did end up doing something else. She ended up leaving to start a company to focus on this. But she, later, almost 20 years later, won the Nobel Prize along with the same professor that she had worked as a lab tech for, on this mRNA research. And so that's, I think, a great example where like the current system is just not optimized for finding people who have a brilliant idea, but it's just a little bit ahead of its time. And so maybe we need to find a way to make space for that within the system.
Yeah. How do you really approve a grant application from a Swedish patent clerk? Like, what system is this that is going to really find out and shift that, oh, those are not so cool, but this is cool? Like, how do we really...
And there is one more thing, that the people who are in this council, they might have their own bias, that they might not even fathom that if you give this idea, let someone explore it, it might lead to some foundational change in the science itself.
Right. Yeah.
There's a lot of bias.
Right. All I'm saying is like we need to make spaces for different kinds of biases, I guess. Right. So right now we have basically consensus committees. So we're biased in favor of the consensus. Yeah. So we need to diversify by saying, okay, if you're biased in favor of I don't know, searching for extraterrestrials, or I'm just making that. But if you're biased in favor of something different than the consensus, we need to find at least some space for that within the system.
Or divergent ideas.
Thinking, yeah.
Right. That's where breakthroughs often come from, is divergent thinking.
So one thing that is happening in science right now is that the capital expenditure for conducting science is becoming expensive. Let's just take AI research. You need to have GPUs and all the state-of-the-art hardware, H100s, and all these things, which academics don't have this. And there has been its shift, like flow of brain from academia to the industry, and industry is reaping a lot of benefits from this academia who have been gotten the education in the, say, public research universities and all these things. So now, there should be a concern, because many of these ideas, when they're implemented in industry, they are not public sourced.
Right.
For example, Anthropic, they have not published any of their research most of their research in NeurIPS or ICML, while they have benefited a lot from this public research, like Transformer, although it came from industry, but it was made publicly available. And there are a lot of such research from academia on machine learning, deep learning, and numerous other fields that have been made available because it was public source. And many times NSF also has clauses that, hey, whatever research you do, you should make it publicly available to everything. And the industry is reaping benefit. It should be a concern. And what can be done to ensure that things are not go everything private?
That's a good question. I mean, I do think I'm not sure what policy lever you could pull to enforce, openness and transparency on internal researchers at Anthropic. I mean, I do think there are examples of, the Transformer paper, attention is all you need. I mean, that's publicly available, right? That was Google researchers at the time, right? So there are at least some examples of transparent results being shared. I guess I would say that what NSF and NIH and other public funders should be doing is trying to focus on their comparative advantage, right? So they can't, you have private companies that right now are spending well in excess of NSF's entire budget, right? So NSF can't compete with that directly. So what they should instead be focused on, I would argue for the most part, is creating public goods like the Protein Data Bank data set that was funded over several decades by several different federal agencies. I don't know the overall cost cumulatively, but that was an effort to create a systematic, well-documented data set that's publicly available. And that's something that industry wasn't going to do, that any one PI and a lab is not going to be able to do that. You need some kind of systematic, organized effort over perhaps decades to create something of that massive scale. And so government should be doing that kind of thing, I think, and focusing its funding on areas where it can provide public goods that then form the basis for future advances that others wouldn't create otherwise.
So one naive policy making idea that I had, it is completely naive, is that maybe government should put like either take a stake on these private companies, or put a wealth tax on these private companies, take the money and use that money as a funding for this public research. That's one. It's probably naive, because it's like you can't just put randomly a wealth tax or take a stake on private companies, because it's government intervention into private enterprises.
Right. I mean, the current administration has been doing things like that already. So, I mean,
but they're not directing it to NSF, for example.
Right. That might be more productive than, for example, trying to, block Anthropic from its most recent models. So I think we should think creatively there.
So one thing, when you mentioned the public goods, I used to work on genomics when I was at the University of Washington, Seattle. And, one discussion among computational biologists at that time was, how much should the NIH, NSF focus on these massive projects like the Human Genome Project? We worked on a project called the IGVF, Impact of Genome Variation on Function, versus the more open-ended research, because those two are already in some kind of tension, because if you allocate $100 million of the NSF budget to these data set creation type projects, then you're so there's a little bit of a zero-sum allocation problem there between that and more open-ended research. So that used to come up in our conversations. And
I mean, that's totally true. Within any given year, the budget for NSF or NIH is zero-sum. But yeah, I think from an overall macro perspective, those agencies' budgets should include a diverse portfolio, just kind of on the same principle that, if you're a typical investor in the financial markets, if you're Warren Buffett, sure, you're a genius. Okay, then invest in whatever few companies you want. But if you're a typical investors cannot all beat the market, right? So your wisest bet is to spread your money out and diversify. And so I think when you're allocating money at the scale of the federal government, it should have and you're kind of the funder of last resort, you should have a diverse portfolio. And so there should be some massive goal-directed projects like the Human Genome Project, or various large clinical trials that cost $100 million that NIH has funded over the years, or the James Webb Telescope, or super colliders, or LIGO. These kind of big efforts that would never happen otherwise. But then at the same time, the federal government and its funding programs should make space. Maybe it's 10%, maybe it's 20%. For just completely open-ended, curiosity-driven research that often looks irrelevant at the time, but it ends up paying off with Nobel Prizes 20 years later. And the federal government can play a unique role in, diversifying across that range of a portfolio and funding some of the stuff that is too speculative and early stage for private investors to want to put much into. Maybe philanthropists could also do this as well if they have a long-term vision. But the federal government, it's existed for 250 years, right? It can take a longer-term perspective on investing in things that have a 10 or 20-year time frame.
That's super interesting. I think the one other place where I used to see a little bit of over allocation is incremental research. This is neither of the two things that you just talked about. One is create public goods that will not be well invested by the industry, and the other one is to bet on divergent ideas. But where I do see a lot of, I would say, wasted public funding is actually in incremental hill climbing type research, which, there is a lot of temptation to do because it's clear and you progress and you can measure it. But it's clearly, substitutable with industry research, and industry probably, is just reaping the benefits without really paying for it, where actually they could just do it internally. At least that's how I used to feel. I don't know if you have a view on that.
Yeah, there are so many people over the years, since the 1970s at least, that I'm aware of, that have said that with regard to NIH, for example, the best way to get funding is to basically propose to research something where you already kind of know the answer. I had an assistant director of NIH once say to me a few years ago that look, we all know when you apply to NIH, you've already done 2/3 of the work that you're talking about in the grant proposal. And there are many other people that have said the same things. There's a neuroscientist I know who says, yeah, when you propose to the NIH, you should have 3 aims in your grant: 2 that you've already done and 1 that you'll never do.
Okay,
yeah,
I thought this was my personal protocol, but it turns out to be a global optimum.
I wrote up a long list of these types of comments once. I'll send it to you.
That is so funny, because the thing in that model, what happens is you then use this NIH money to do the next thing, which then you don't even need to disclose to the NIH what is that next thing. But that then, like, you can, once it's done, you can go and tell them, hey, I'm going to do this.
Right. No, that's I think that is kind of inherent to this consensus-driven approach, where, to especially at NIH, they have these peer review panels or study sections that have 15 or 20 people and that are peers in your field. And it's so competitive to get NIH funding. It's often just the top 5% of proposals that are getting funded. So if a few people say, that'll never work, or that's too creative, or it's not opposed to my view, then
you're out.
You're out. And so, there have been many people who thought that maybe some of the best ideas might come from a place where, like, one peer reviewer says, this would be amazing if it worked, and another peer reviewer says, oh, this will never work. Right. And you get this divergence of opinions because probably a lot of great ideas would be viewed that way at first by your peers in your field. Maybe someone might see the potential and others will say it will never work. So that's, yet another problem with, like, looking for, like, everyone to vote and give it a score, give it a ranking, and then we'll take the ones with the highest average score. Right. So now you're selecting for the stuff that everyone is sure is going to work and that is more incremental, more likely.
This could be the divergent algorithm, is to basically, like, fund a portion of the things which, instead of working on the least opposed things, the things that have at least a few people give their most enthusiastic support, and few others may even just, like, hate it. The polarizing ones that you just, like, said, I think is a very good protocol, because I also used to see this at the university admissions, like the faculty recruitment committee. That when, because it's a vote of the faculty, and, like, the least opposed candidate would get through. And I was actually a big proponent of, we should take the ones who have the most smaller group of people who have the most enthusiastic support, even if others vehemently oppose it.
Right.
I think it's an interesting algorithm for divergent thinking. We've talked a lot about general science funding. What are the trends that you see that are going to amplify or minimize or change in the presence of AI, AGI, in your view?
I mean, it's interesting. So I think one trend that we could see, depending on how the IPOs go, that are, there's several major ones that are happening or about to happen. One major trend could be that there's a lot of people that are newly minted multi-billionaires or billionaires or 100 millionaires, right? and who have a lot of money and who are perhaps interested in doing philanthropy, but they also have a very busy day job. And a lot of them are very technical and will have some interest in science. So I think probably the flow of money from AI back to science could be very interesting over the next several years. And there's someone named Nan Ranselhoff who recently wrote an essay on this, kind of making some projections about the potential.
Open philanthropy.
Yeah, about the potential impact of all this new philanthropy. So I think that could be one of the most interesting things. And the federal government, this doesn't have to do with AI per se, but there are some new initiatives. There's one at NSF called XLabs, which is committing $1.5 billion to, right now, to two main lines of funding. One is to, like, instrumentation, and the other is to, like, quantum related stuff. But it's funding for initiatives and organizations that are not controlled by universities. So they're specifically trying to fund new organizations, maybe startup research organizations, focused research organizations, and they can be maybe kind of aligned with universities, but not fully controlled. And so, and there are folks interested in doing the same thing at NIH. So there may be possibilities to expand the range of scientific funding that way as well.
So on that model, is it like an incubation model? For example, the federal government, like, instead of giving just pure funding, it's like, I'm giving you funding right now, but if you spin up a product out of this, I'll have, like, X percentage of stake in that product. It's like being a VC. Like that you're making a bet, right? So generally what happens in all this federal funding is like, yeah, I'm giving you money. There's a committee who said that that research is good. You just have to put whatever research artifacts you get out of your research, it should be put in a public domain. But you can go like further. Like you can say that, oh, maybe you can be entrepreneurial out of your research, make a product out of that, and I want a small stake, X% in your thing. Then what happens is that when those companies, like out of 1,000, maybe 10 of them will become a successful product, but then the federal government has a stake in that in public markets. When they go IPO, you can like they can get returns out of that, right? It's like a VC model, but government is adopting that. Has there been such experimentation or thoughts around this?
I actually don't know. I mean, I know historically, prior to 1980, the government used to just keep patents on whatever came out of federally funded research. And then there was an impulse at the time. They passed something in 1980 called the Bayh-Dole Act, named after a couple of senators at the time, that basically said, look, government is not doing enough with these patents. They're not commercializing. Government doesn't know how to do this. And so now if government funds, in most cases, universities, because technically the government funds the university and the university then employs the scientists. The government doesn't fund the scientists directly. So they said the universities will presumptively be kind of in charge of the patents. And then there's some complicated conditions that I can't remember them all, under which, like, if the university isn't exploiting the patent, the government could kind of step in and take some of the value of that. But yeah, that's been kind of the framework for the past 46 years. And it might be worth rethinking that, because there is some evidence from Europe that, like, letting the professor themselves or the inventor themselves have control of the patent might be more efficient than the university, which itself, it gets tied up in these tech transfer offices that sometimes try to take too much equity in companies or are too slow and inefficient. They're their incentives are not fully aligned but the professor or the inventor might have much more of an incentive just to, like, work directly with VC or to commercialize an invention. And I could imagine, if we're starting from scratch, a system that made a lot more sense, where you let the professor or the inventor have the patent, but then you just say, all right, the university gets 5% and the government gets 5%. And we're not going to waste time. We're not going to waste a year negotiating over every deal from scratch, and then just go for it. Like, go try to make as much as you can if you came up with a company. So that would probably be better for everyone, because right now we just waste a bunch of time.
I totally agree with that. This the one thing that we saw in some of our work on trying to, for example, build this open network where people collaborate using agents to actually try to do some kind of scientific discovery. The super interesting things that we saw are, one is there are problems that appear very intractable to, like, an AI to direct it. For example, build a better quantum computer looks like a crazy unspecified problem. But if you distill it to, like, hey, build a quantum circuit in this format, which can, do elliptic curve addition with 10,000 random points, whatever, something very specific, and minimize the number of nodes in the circuit or something, that suddenly becomes highly tractable. And so, but you need, like, pretty sophisticated scientists to take that, like, crazy, build a quantum computer problem and distill it into, like, this is a very interesting objective version of this problem. And then once you set up the objective, the thing that we saw, which was very, very surprising to us, is the rate at which, in academic work, you write a paper, you put it up, you hope the other scientists read it. And then once they read it, they're going to, understand, improve, and make progress on it. But seeing all of that kind of, like, distilled into days, where each person with an AI agent comes in and they do a PR, and, like, there's all this GitHub, code used for collaborating across these things, and they just, like, build on top of each other's ideas. This was pretty incredible coming from that academic background. So I feel like over time, there's going to be this massive compression of the time period needed for open scientific collaboration, because, it's not just, the scientist operating at the resolution of each of the details of the paper, but the scientist is directing in two ways. One is this distillation from the high level problem to a specific objective problem, and then directing agents to actually go attack this problem. I want to get a kind of, like, your high level read on. I mean,
I guess my hope would be that something people have talked about for over a decade or more is that it makes no sense that the main output in science, the main output that's rewarded by universities, by tenure committees, is, like, did you write an academic paper that came out in a journal, and now here's a PDF that we can print it out. I've heard scientists will say, yeah, when I went for tenure, they cared how high was the stack of papers that I could put on the table, right? Whether it was any good, like, was anyone going to read all this? Like, they just cared about the papers and the journals it was in. And that makes no sense in today's environment. It made no sense 10 years ago, right? Just based on what we have with the internet. But it makes even less sense in an environment where people can be deploying AI agents to, whether it's investigate data or whether it's to investigate this specific types of problems that you're talking about, or whether it's to reanalyze take someone else's code and data and reanalyze it and extend it. And that should be happening with kind of rapid feedback loops and not based on the cycle of, submit something to a journal and, a year later it's peer reviewed and it comes out and it's already outdated and it's in a static format. That format just does not make sense. And hopefully the scientific system and academic system can evolve away from that very rapidly. But yeah, again, people have been talking about that for years, and again, like there have been archive that's existed for a long time, and there have been efforts to do that in other disciplines. But I mean, the archive mostly you click on stuff on there and it pulls up a PDF, right? It's not like an interactive environment. So even that's pretty stuck in the past.
I think the best example comes from the AI community, because I think AI went through a dramatic transition with the presence of ImageNet, the first large-scale data set, and a benchmark-oriented culture. Everybody just obsesses about these nowadays, whatever is the latest, SweBench Pro or whatever the coding benchmarks are, obsesses about this one benchmark and the ping pong that you see on, I hit this thing on this paper and you improve it and so on. I used to initially think this reduction of the paper minimum publishable unit of a paper from something much more substantial to there's a next NeurIPS conference, let me just bundle up something and write it. I initially thought it was actually a counter pattern to scientific research, but I'm now realizing that actually it lets people build on top of each other with much more smaller units of ideas than were possible. So it just made no sense to count the number of papers in that world.
Right.
But the rate of progress, just doing GitHub pull requests, each scientist, in this quantum benchmark, we saw thousands of submissions in a few days, right? Each one's very incremental. They just move the thing by 0.01%. But over 7 days, we've actually had a 15x improvement in the state of the art.
Well, now you're making a case for incremental. So in a way, but you get enough incremental stuff iterating on each other and rapidly.
But that is the right form factor of the iterative.
In aggregate, you
actually make a lot of progress. Right. But I think the hardest part of this is actually setting up the objective verifiable benchmark, whether it's through the protein database, the human genome sequencing, or some kind of cloud lab, or whatever the interface is through which you can actually objectively verify the outcomes of these scientific, artifacts. Because if you didn't have it, this kind of fast ping pong is simply impossible. What does it mean you improved the thing by 0.0001%?
Right.
That has no basis. But once you have it in an objective verifiable benchmark, then you actually can.
So this talks about something about this setting up programs. Like math had this something called Langland's program, and
Hilbert's 30 problems.
So some eminent scientist or a group of eminent scientists come together. They set up this benchmark, this objective criteria, and then it leads to a lot of people flooding in.
Even the Erdos problems, and now the AI community somehow picked up that Erdos problems are the things to solve.
So basically, I think the gist is that we have lack of such programs in science. There are few, you can count probably in some tens of not even hundreds, probably tens of order. But we need more such programs, it seems, and where people can cohere around those programs and do ping pong and evolve over each other's idea at a very machine speed. Right now that it's AIs are there, just do it in machine speed. That will be the ideal case.
Yeah. I mean, let me make 2 points. I mean, I agree with you that seems like it could be really useful in lots of areas. At the same time, let me ask you, to what extent do you worry that people end up overfitting to a particular benchmark that may not then generalize outside to new areas or even adjacent areas. Is that a problem you worry about? I'm not.
Yeah, that's a worry. And then maybe people will come up with new benchmarks. Someone will figure out, oh, this does not robustifies against something else.
I think like you can see this again from the AI community. There were benchmarks which were non-saturated and very hard. So this is one of the things that the AI community can use to measure is like how saturated are the benchmarks. If you're up above 90+%, then using that as a guide to channel effort seems less relevant. So people say like, oh, those benchmarks are already saturated. Let me build the next grade of benchmarks.
You can see real time this is happening with the software benchmarks, coding benchmarks. This is what happens. SuiBench came, then SuiBench Pro came, then God knows what else is coming.
So now it's called Agents Lost Exam. Like there's just like, one benchmark after the other, people just keep coming up with that. Then but I think that requires some taste and subjectivity, which is not like, it's not conducive directly to agentic research. Which benchmarks are right? Like that is not an easy problem.
And when it comes to some fields like biology, like should we be thinking of benchmarks, multiple benchmarks that are in some degree orthogonal to each other so that you can't overfit too much for one?
Yeah, absolutely. Right? Exactly. I think like there are these multi-objective problems, right? You don't want to just set up one objective because, minimize toxicity, maximize survival rate. Like there's going to be like a bunch of different things that you would want simultaneously, and you would absolutely need to set them up. This is, I think, if our hope and belief is that this becomes the era of intelligence becomes a golden age of science, and we want this to be a golden age of open science. Yeah. I think it is going to be a golden age for science, nevertheless, but we would love for it to be a golden age for open science, that all of us can participate, contribute, improve, because the divergent thinking that actually comes from opening it up will be sorely missed if we go the other way.
Yeah, totally. And to iterate, like the degree to which science is open also helps with the development of future AI tools and AI models, because again, I would hate for it to be the case that like just all the new development is like in some enclosed environment within one of the frontier labs. And then, the benefits don't flow. The benefits are much more concentrated and less open and free to the public and to the rest of the scientific community.
Yeah, so that is something that we're very passionate about. In fact, it seems like one of the things that NSF should have done, or like, we want to play a part in it, is to actually build some kind of an open alternative to recursive self-improvement that these big labs are after, which is in an intelligence that can keep improving itself, but not on its own directive, but with the kind of like the inputs and openness that comes with open scientific research, that actually you have a place where all the scientists can come in and plug in and contribute and keep moving the state of the art, which then helps to move everything else along. So I think that is something that we're pretty passionate about.
Yeah. I mean, are there any proposals for NSF to do something like that? I mean, there's been the Genesis mission, but that's under the Department of Energy, and it's not clear to me that that's working very well so far. But I haven't
seen proposals like this, but I think it would be something we're super excited about.
There is this one question we are asking each of our guests. Okay. It's, what is one thought that you have that is about post-AGI society, post-AGI economy, that is contrarian to widely held beliefs?
That's a good question, because I'm not sure how many people are even thinking about this. There are widely held beliefs about post-AGI society. I mean,
it could be post-AGI research institutions, anything, funding.
Yeah, I mean, I don't know if this is contrarian, but I guess my belief would be that like we as human beings are going to find some new way to find meaning and meaning in our existence and our relationships to each other. That even if there is some artificial general intelligence that surpasses us, that we will still find ways to find meaning in the universe.
Amazing.
Amazing. Thanks. Thanks Stuart,
so much. I really appreciated this conversation, and good luck to you on the work on Good Science Project.
Thank you.